Okay, company sells widgets. The amount of profit Y that they can make made by the company is related to the selling price of each widget, which will be the X value, by the given equation. Using this equation, find out the maximum amount of profit the company can make to the nearest dollar. So we can tell that this is going to open down. It's going to be a parabola that opens down. So it's going to look like this. So this point right here, the vertex, the maximum point, that's going to show the maximum profit. And the X value at that point would tell you the price of the widget that would give them the maximum profit. So, I mean, we could figure this out by figuring out the vertex. So we'd figure out the X value of the vertex by doing the negative b over 2a. But given the numbers that we're given, I think they want us to take it to a graphing calculator because those are not friendly numbers at all. So we'll do that. We'll just type this in. It was negative x squared, and then I've already forgotten, plus 51x minus 164. Now this will give us, yeah, there it is, the parabola, and we need to find the maximum point, which is going to be right there. Okay, so that tells me that, remember, 25.5, so that would be the price for each widget, and 486.25, that would give us the maximum profit. So it wants to know the maximum profit. So it's going to be 486.25 to the nearest dollar. So that's $486. If they'll allow me to put the dollar sign in there. 486. Yes, okay. So let's do another one of these. A rocket is launched from a tower. The height of the rocket, y in feet. So let me grab a shot of this again so I can use my highlighters. So the height of the rocket, y in feet, is related to the time and launch in seconds, or times after launch in seconds. Using the equation, find the maximum height reached by the rocket to the nearest tenth of a foot. So we're going to be looking again for the y value. So again, we're not going to mess around with the vertex formula and plug in the value here because it's going to be way too complicated. So let's go ahead to Desmos and type this in again. We had negative 16x squared. I think it was plus 135, no, plus 235. Plus 235x plus 67. Okay. There it is. It's a maximum height after reaches its maximum height after 7 seconds. 7.3 seconds, and its maximum height is 929.9. I just want to do one more because sometimes you're not looking for the y value. Sometimes you're looking for the x value. So in this one right here, the height of the rocket, y in feet, is related to the time after launch, x in seconds, by the given equation. Using this equation, find out the time at which the rocket will meet its max. So time, we're looking for the x coordinate this time. So we can type in this same equation into into Desmos. It was plus 242 plus 84. And this time, we're not looking for the height, we're looking for the, I think it was the time, right? Yeah, the time at which. So that would be 7.5 seconds. How do they want that to the nearest hundredth of a second? So it's actually 7.56. I'm going to come in here. It's going to be 7.56 seconds. That's when it will reach its max. So you just got to be careful. You got to make sure, is it asking for the y? Is it asking for the highest profit? Or is it asking for like the time? If it's the time, it'll be the x. If it's height or profit, it'll be y.